Hello everybody, I'm Nick, and in this video I'm going to introduce you to the thread safety issues of the random class in C# and .NET and show you exactly how it can fail and explain why the way it fails is very, very dangerous. It's something I came across myself and there's a lot of material covering the topic, but I want to bring all that advice here and just present it to you. Now, this is something that Microsoft has tried to address to a degree in the latest .NET versions, but it is still here, and I'm going to show you exactly where it is in those versions and what you can do to prevent it. If you like that type of content and you want to see more, make sure you subscribe, ring the notification bell, and for my full-length courses, check out nickchapsas.com. Okay, so let me show you what I have here. I have a .NET 5 application over here, and we're going to start with 5 and go into 6 because we need to understand exactly how the problem has evolved as well, because Microsoft knows about this. Now, first we're going to see exactly what the problem is, but before I show you the problem, I want to let you know that if you want a cryptographically random number generator, you want to use the random number generator class. You don't want to use random. The random class is just for generating random data, but it doesn't really matter if they're cryptographically random or not. And I'm using that quite a bit in my applications where needed. Now, to demonstrate the problem, first I'm going to create a random class. So random, and most of you are familiar with this. What you can do is generate random data, so a random integer, random bytes, or random double number. You can keep calling it and it will generate a random number. You can also pass down a seed if you want, and then that will return deterministic random data. So every time you generate a new random object with that seed, every time you call next, the same sequence of numbers will be generated basically. Now that I have the random object, I'm going to bring in a parallel.for loop just to simulate some multi-threading and actually cause it to fail and see how it fails. So this is the loop, and at first glance, this is just all looks absolutely fine, right? I have 10,000 numbers in 16 different threads over here. And then all I'm doing is rng.next, and I'm setting the value into that array. Now, as opposed to other things that will throw when they fail, when there's a thread safety issue detected, random.next will actually not throw. All it's going to do is set the value to 0. And that is dangerous because for me, it was silent. I never noticed. And then I saw all of those zeros in my use case. And I thought, wait, what? What's going on here? So depending on how multi-threaded your application is, if you're not dealing with this correctly, it can cause unintended behavior. And I don't know what 0 might be for your application, but for someone, it might be very, very important. So to detect that problem, I'm going to add these couple of lines here. So all I'm doing is getting the count of zeros in the array. Ultimately, it shouldn't really have any, but with the thread safety issues, it will. And then I'm just getting that number and I'm printing it. So all I'm going to do is just run this in release mode, which is the more optimized version. And as you can see, we're detecting some zeros in there. I'm going to run it again. And these zeros can change over execution. But these are basically individual thread safety issues with random.next. Now, you can technically solve that problem by bringing in the random in the execution context and then basically have one random per thread. And if I do run that, then yes, this will have no issues at all. But because random is, as you can see here, a class allocated on the heap, you will generate a lot of random objects that you will need to garbage collect, and that can slow your application down. Now, let me put this back up here and let me show you that this random constructor is way different than what we're going to see in a second when we're going to move into .NET 6 to see how this problem has changed. Just remember, when it's outside of the scope of the Lambda over here and I execute that, so I'm sharing the same random, then I have the thread safety issues in .NET 5. And as you can see, 10,000 here. Now I'm going to go ahead and change this to .NET 6, not change anything else, and then go back here. And I'm just going to run the exact same code again in .NET 6. As you can see now, no thread safety issues. Oh, so you're thinking, oh, they fixed it. That's it. There's nothing to worry about. Well, let's pass down a seed now just to generate those deterministic data. Thread safety issues are back there. So one of the constructors is safe. The other one of the constructors, the one with the seed, is not. Now let's see why we have this behavior. First, I'm going to start with the random, the empty constructor, and I'm going to go here. And as you can see, it has a get type check. So if the type of itself of the random is equal to random, so it's not inherited in any way, then it's going to use this Zoshiro implementation. Otherwise, it will use the net5 compatible derived implementation, which is very interesting because that kind of tells me that what if I have a derived my random type and just implement random or extend random, and that's it. And now I'm going to run it again with the random, the safe random, because this will go into this implementation over here. But then if I go and say my random and nothing else has changed in this application, I just extended random to my own type and I run it, then thread safety issues are back there again because it's going to fall back to the previous net5 implementation. Now I'm going to show you something else. Back to random, back to the working one. But if I now pass down a seed and I run this, thread safety issues are back here. No seed, all works. Seed, it breaks again. So what exactly is happening over here? Well, as you can see in the seed constructor over here, we still have the getType random check, but we go into a net5 compatible seed implementation and net5 compatible derived implementation, while in the non-seed constructor, we go to this Zoshiro, which seems to be the safe approach. Now, in .NET 6, there was actually a new random thing added called random.shared. And now you can share this random object. And if I run this, this is now thread safe. You can just reuse it, no problem. In fact, you would not even create an object. You go down here. But this approach does not support a seed. So if you do need deterministic random data generation, you can't really use that. Now, I want to take a step back, and I'm even going to go back to the net5 implementation, the one that doesn't work with the new random. So even that is not fixed, and try to fix it myself. And I try to understand how we would fix something like this ourselves. So just to recap, this in .NET 5 fails with thread safety issues. Now, how do we fix that? Let's go ahead and create a concurrent random class. And I'm going to change this to a static class. Now, my main problem is that random is not thread safe. But if I only have one random per thread, I wouldn't have that problem. So that's what we're going to do. I'm going to create a private static random that is nullable and call it local. And what I'm going to do is slap the thread static attribute on it. Now, I don't know if you've seen thread static before, but basically what it will do is it will guarantee that I'm only going to have one instance of this per thread. So not a global one for everyone, one per thread. And since my problem is multi-threading, this should solve the problem. So what I want to do is say public static random and then instance or value, depending on how you want to name it. And then that is random, but when it's nullable, initialize it with a new random. And now what I can do is comment this RNG out and just use concurrent random here directly .instance and next. And if I do that, then I have no thread safety issues. No matter how many times I'm going to run this, it's not going to have any issues because I'm only going to have one instance of that random field per thread. Now, the problem with this approach is that if I go back to the RNG approach and comment this and then say RNG equals that item, then I still have that problem because I'm capturing that single instance and then resharing it. To prevent that, all you want to do is create a new public static int next method and then say instance.next through that and then make this one private. So the only way you can actually use that now is say concurrent random dot next, and that's it. And this will solve all the problems you might have with this approach. So what's the summary of all this? Well, if you're in .NET 6 and up, use random.shared, but if you need a seed, you're in trouble because the seed constructors are not thread safe, but in versions before .NET 6, know that even the new random constructor, the parameterless one, is not thread safe, while in .NET 6 it is. It's a very interesting little problem that can cause quite a bit of trouble if you misuse it. So check your applications, give a scan, and see that you are not using this feature incorrectly. Well, that's all I had for you for this video. Thank you very much for watching. Special thanks to my Patreons for making videos possible. If you want to support me as well, you can find the link in the description down below. Leave a like if you like this video, subscribe for more content like this, ring the bell as well, and I'll see you in the next video. Keep coding.